Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today, logarithm. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to understand and use the laws and properties of logarithm. So we are going to learn about the laws and properties of logarithm and how to use them to solve questions. You should be able to solve equations involving logarithm. So you use the laws and properties of logarithm to solve equations involving logarithm. Let's learn more about logarithm. The logarithm of any number x to the base y, which is written as log x base y, is the index or power to which the base must be raised to give the number. So if you have the logarithm of a number x to the base y, it's written as log x base y. Okay, so if you see log, then you have 2 here and 3 here. This is read as log 2 base 3. Okay, so the logarithm of any number x to the base y, which is written as log x base y, is the index or power to which the base, in this case y, must be raised to give the number. So the index or power to which the base y must be raised to give the number x is what we call log x base y. That is, if log x base y is equal to a, then the logarithm number, which is x, is equal to y exponent a. So the index or power to which the base y must be raised to give the number x is what you call the logarithm. So in this case, a is the logarithm. So the logarithm of x to the base y, if that is equal to a, then x, which is the logarithm number, is equal to the base, which is y exponent a. Okay, we are going to solve more questions on this. Remember that y is positive, so the logarithm base is positive and is not equal to 1. So the base of a logarithm cannot be 1 and it must be positive. So y, which is the base, is positive and is not equal to 1. Let's learn more about logarithm. The base of logarithm can be written in any positive number except 1. That is what I said here. The base of a logarithm cannot be 1. So y here cannot be 1. And it can also be written in any positive number, which means that y here must be positive. And the logarithm of a negative number does not exist. So here the logarithm number, which in this case is x, cannot be negative. Sorry, the logarithm number cannot be negative. So you can't have log negative 2 base 3. Okay, so the logarithm of the logarithm number, which in this case here is x, cannot be negative. Remember that the logarithm base here must be positive and it must not be 1. Okay, when the base of logarithm is not written, sometimes the logarithm base here will not be written. You see here we have log 2 base 3. Sometimes the base will not be written. If the base is not written, it means it is in base 10. Okay, so if you see this, if you see log 4, oh sorry, I'm going to clean it so that I write it well. Okay, so let's say that you see log 4, log 4. if you see log 4 like this, now you see that in this case, the logarithm base was not written. This means that it is in base 10. So this is the same as log 4 base 10. So log 4 written like this is the same as log 4 base 10. Okay, so we've learned a lot about logarithm here. We've learned that the logarithm of a number x to the base y is the index or power to which the base must be raised to give the number. So if you have log x base y and this is equal to a, then x is equal to y exponent a. We've learned that the base of the logarithm must be positive and it cannot be 1. We've also learned that the logarithm of negative numbers does not exist, so the logarithm number cannot be positive. And we have also learned that if the base of a logarithm is not written, it means that it is in base 10. Let's use this definition of logarithm that we've studied to solve some questions. Okay, so use the definition of logarithm to evaluate the following. We will solve the first one in this video, then we will solve the others in the subsequent videos. So the first one is log 81 base 3. We've learned in the previous slide that if we let log 81 base 3 equal to a, then the logarithm number, which is 81, so from the definition of logarithm, if log 81 base 3 is equal to a, then the logarithm number, which is 81, is equal to the logarithm base, which is 3, exponent the logarithm, which is a. I hope it's clear. So log 81 base 3, if that is equal to a, then the logarithm number, which is 81, is equal to the base, which is 3, exponent the answer here, which is a. So we have 81 is equal to 3 exponent a. From indices, we saw that we can express 81 in index form such that it has a base of 3, because 3 exponent 4 will give us 81. So we have 3 exponent 4 representing 81 here. So if you write 81 in index form such that it has a base of 3, you have 3 exponent 4. And this is equal to 3 exponent a. We learned in indices that if you have an exponential equation and the base on the left hand side and the base on the right hand side are the same, then you can equate the exponents. So the base on the left hand side here is 3. The base on the right hand side here is 3. So we can equate the exponents. So we say that a is equal to 4 or 4 is equal to a. But what is a? A is log 81 base 3, which means that log 81 base 3 is equal to 4. So the logarithm of 81 to the base 3 is equal to 4. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. In the next video, we are going to use the definition of logarithm to solve more questions. Bye bye.